Alrighty, so today we're going to be looking at factor theorem and factorizing cubics. And I guess the main question that we're going to ask ourselves is, how do we know what the roots are? How can we figure out the roots? Now, in quadratics, we have a few tricks for factorizing, and that's really useful. But what does it actually mean for something to be a root? Well, it means for an x-intercept, which is what a root is, it means when y is equal to 0. But y is just f of x. So we're interested in when the function's equal to 0. So really we're interested in when is this equal to 0, but rather than looking at this isn't very useful. Let's look at this instead. And so we can think about if this was some nice polynomial, if it had a nice factor, right, it could be x minus a and then times some kind of quadratic. Ax squared plus bx plus c, right? If this worked, this would be a factor. Now, what the factor theorem says is that if p of a is equal to 0, then that must mean that x minus a is a factor of p of x. What does that mean? Well, for it to be a factor, it means that when we divide, we won't get that fraction bit that we got on the previous one. Meaning we could truly write this as x minus a and then some kind of quadratic thing, which would be really useful because we already know how to factorize quadratics. That's going to be the goal. So then the next question becomes, okay, well, how do we work out what a is? Well, for a, we always look at d, the constant term. So a needs to be a factor of d, the constant term. Okay? Or, in the case, so like a is just like our guess, right? So let's have a think about what a could be. Well, so these are our guesses for our roots. So a needs to be, well, let's have a think about what it could be. Well, plus or minus 1, plus or minus 2, plus or minus 3. 4 is not a factor of 6. 5 is not a factor of 6, so it's 6, plus or minus 6. So those are the factors of 6. So if this is a nice cubic, and for most part we're going to be looking at nice cubics, one of these has to be a root of this, meaning if I substitute in x equals one of these, well, one of them should give us a 0. Let's have a try. So let's try p of 1. Well, p of 1 is equal to 1 to the power of 3 minus 2 times 1 squared minus 5 times 1 plus 6. 1 to the 3 is 1. 2 times 1 is minus 2. Minus 5 plus 6 equals 0. Therefore, since it's equal to 0, therefore, x minus 1 is a factor. Now, just to show that this was like a lucky choice, let's try p of negative 1, just to show that it's not always going to work. So we're going to get negative 1 to the power of 3 minus 2 times negative 1 squared minus 5 times negative 1 plus 6. In this case, we get negative 1. Negative 1 squared is 1, so negative 2 plus 5 plus 6. 11 minus 3 is 8, which is not equal to 0. Therefore, x minus minus 1, or for short, x plus 1, is not a factor. Alrighty. Now this whole step down here was just optional. I'm just showing you that, we were lucky that p of 1 actually worked out. In general, you'd have to try plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and maybe only one of those works. Okay? So just be mindful, we're lucky in this case, not always going to be lucky. Okay, so where do we go to from here? Well, we now know that this is a factor, which means if we divide by this, we're going to have a good time. So let us do polynomial division. So now we know the factor, x minus 1. Let us divide our original function, which was x to the 3 minus 2x squared minus 5x plus 6. Okay? So now we're doing the polynomial division. We know what to divide by. This is what we're dividing by. Now we need to actually complete the division. So let's do it. So how do I make x minus 1 look like x to the 3? Multiply it by x squared. Expand those brackets, I get x to the 3 minus x squared. X to the 2 goes up here. Alrighty. Now I need to do the subtraction. X to the 3 minus x to the 3 is 0. Remember, that's the whole point. Minus 2x squared minus x squared. Well, minus is actually plus x squared, so minus 2x plus x is going to be minus x squared. Alrighty. So we've done the first step. Now we're going to bring down the minus 5x. Now the question is, how do we make x look like negative x squared? Well, we've got to multiply it by a negative, and it needs another factor of x, so negative x minus 1. Negative x goes up the top. Expand the brackets. Negative x squared plus x minus is plus. Now we're going to do subtraction. Minus x squared minus x squared is 0. That's the whole point. Minus 5x minus x is minus 6x. Plus 6 comes down the end. And this is looking quite nice. Looks like it's going to work out just perfectly. Alrighty, how do I make x look like negative 6x? Multiply by negative 6. Minus 6 goes up the top. X minus 1. Notice you know the x minus 1's in every single line. Expand the brackets, we get minus 6x plus 6. Hey, look at that. 0 plus 0. No remainder. Therefore, we can write this whole thing as x minus 1 times x squared minus x minus 6. And we have just factorized the first bit of it, right? Perfect. That's looking great. Problem, that's still a quadratic, and we can factorize that really quickly just using our t-chart. So t-chart times to negative 6 adds to negative 1. It could be negative 6 and 1. That doesn't work. Negative 3 and 2. So it's going to be negative 3 and 2. Since it's a monic, I am just going to skip the step. So it's going to be x plus 2x minus 3. And we are finished. And we're all done. Alrighty. So we have factorized it completely. How did we do it? First of all, we looked for all its potential factors based on the d term, the term at the end. We guessed and checked until we found one that worked, and then we divided by that factor to turn it into a linear thing times a quadratic, and then we factorize the quadratic just by doing usual quadratic stuff. So that is how we can actually factorize cubics. I'll see you in the next one. Goodbye.